Okay, so let me just get this to settle. We're on to our thinking portion of the day. And so Kevin and Joe are cross-country training. They've recorded their practices and distances. And so I've made a chart for you guys over here to reflect those practices and distances. So in practice number 1, Kevin ran 1.5 kilometers, Joe ran 3.5 kilometers. In 2, Kevin ran 3 and Joe ran 4.5 kilometers, and so on and so forth. So we have to do the following. We have to write ordered pairs. We've got to write the algebraic rule, we've got a graph, and we've got to answer an inference, okay? So let's do the first one first, ordered pairs. Now, here's the issue. We have two different people that we're going to be graphing, so we have to identify using two different colors. So we're going to do Kevin in this pinkish color and Joe in the blue color. So Kevin's first one is going to be 1 and 1.5, 2 and 3, 3 and 4.5, and hopefully you guys can see it down there, 4 and 6. Whereas Joe's is going to be 1 and 3.5, 2 and 4.5, 3 and 5.5, and 4 and 6.5. Okay, so our ordered pairs are done. Again, even if they have decimals, it's totally fine. We've got to write an algebraic rule. So again, we have two people, so that means two algebraic rules. So let's do Kevin's first. So we look at Kevin's and we say, okay, what's the increase? Well, this is 1.5, 1.5, and 1.5. So we know Kevin's algebraic rule is going to start with 1.5n. So now we just got to see if we go backwards by 1.5, we get the 0. So the 0 term is 0, which means that this should be the only pattern rule. Well, let's test this out. 1.5 times 1 is 1.5, which is what we need it to be. So Kevin's pattern rule is 1.5n. Great. Joe's pattern rule, let's see, Joe's goes up by 1, and then goes up by 1, and goes up by 1. So Joe is n, but Joe's going to be a little bit more complicated because Joe, if we do 1, does not equal 3.5. So we need n plus 2.5 is Joe's. Okay, so we've done the algebraic rules. Let's graph it. Now, because again, we're doing two plotting points, we're going to have, again, a graph. I'm going to do a graph over here so we have a little bit more room. You can kind of see. We need a graph that kind of will be able to distribute both people. Now, we'll start here at 0, 1, 2, 3, 4. Again, the x-axis is our first one, is our first number over here. Our first number represents the practices, so we're just gonna write that, and this is kilometers, okay, on the side. Now, we're seeing a lot of decimals, so we could make the decision that we can start at 1.5, and we can go up by 0.5. So 2, 2.5, 3, 3.5. That might make the most sense to get a really good plotting point. 4.5, 5, and we'll continue on there. We'll leave out the 6 just for now. Okay, so now the same thing applies. We're going to, because we've dealt with Kevin's in pink the entire time, we're going to do the same thing. So 1 and 1.5 is Kevin. 2 and 3 is Kevin. 3 and 4.5 is Kevin. And 4, and it would be 6 up here somewhere. So we can actually just put that in there, and I'll just add it on the side just a little bit. 5.5 and then 6. And I know that what's his name has a 6.5, so we'll put that up there. Okay. So what I want to do is I do want to draw out Kevin's line. I don't have a ruler, so please make sure you use a ruler. And let's do Joe's now. Joe is 1 and 3.5, so Joe's all the way up here. 2 and 4.5. 3 and 5.5. And 4 and 6.5. And so Joe's is like this. So we've graphed them both. At what point will they catch up? That's kind of where we're looking at next. So if we continue this trend at the 5th practice, let's plug these in. So at the 5th practice, Joe's is n plus 2.5 and Kevin's is 1.5n. Oh, you guys can't see that, sorry. So at the next practice, if we did that, Joe would have 5 plus 2.5, which is 7.5. And Kevin would have 1.5n. So he would have 1.5 times 5. 5 times 1.5, 25. 7.5. So at the 5th practice, Joe and Kevin are now on the same level. So what kind of inferences can we make from this chart? Because this is something that you will need to learn how to do. Well, you can see that Kevin's progression is greater throughout. Although Joe starts off running further, he doesn't run as far every other time, whereas Kevin's making larger progressions. We can also infer that if they practice for much longer, Kevin is going to be the better runner of the two because he's going to surpass Joe at the next practice, and then Joe will not be able to catch up. So that's some ways that we can make inferences. Let's try one more with you guys, a thinking question. Now this one doesn't have a graph in it because I think the progression of graphing is pretty solid with you guys, but it does have something that I know that a lot of people wrote down in their exit cards that they were still a little bit confused on. So here we go. We got figures. There's orange and there's a blue pond area, and there's some orange tiles that are like the border, and you can see figure 1, figure 2, figure 3. So sorry, I thought I took this out. I don't want you to chart both A and B. I think you can chart, you've charted enough. I want you to, if you want to, go right ahead, totally up to you. Write the algebraic expressions for both the orange and the blue tiles. Which figure would have 56 orange tiles? So I want to know which in the term numbers, which term number would have 56 orange tiles, and which figure would have a pond area of 121. Okay, so take a pause, and then we'll come back and we'll work through this progression. Okay, go. Okay, so this was a more challenging one because you had to kind of create a different type of table. So you've got your figure, you've got your orange tiles, and you've got your blue tiles. So in figure 1, we have 3, 6, 8 orange tiles and 1 blue tile. In figure 2, we have 4, 8, 10 orange tiles. No, 12 orange tiles. Yep, 12 orange tiles, sorry. And 4 blue tiles. And in figure 3, we have, I think it was 16 orange tiles and 9 blue tiles. Fob, that's not good. So we want to treat these totally separately. So when we're writing these algebraic equations, we're going to look at, the figure in the orange tiles as one algebraic expression, and then the figure in the blue tiles as another algebraic expression. So let's do the orange tiles first. So what is the movement here? Let me get a different color so we can see it. What's the movement? From 8 to 12, it's plus 4, and from 12 to 16 is plus 4. So the orange tiles, let's go over here, is 4n. Now, this is one of those ones where you can go backwards. So if we go backwards by 4 to get to the 0 figure, we'll end up at 4. So the answer would be 4n plus 4. We're going to need to hold on to this one because we're going to need it for the second part, okay? For the orange tiles, sorry, for the blue tiles, we have figure 1 is 1, figure 2 is 4, and figure 3 is 9. So the progression here is 3 and then 5, and this is usually a clue that we want to use a square. right? So we're going to write n squared, and we're going to see if we need any constants here. 1 squared is 1, so that's good. 2 squared is 4. 3 squared is... So the blue tiles, that's n squared. The orange tiles is 4n plus 4. So we've written our algebraic expressions. Remember that we looked at this and we said this is nonlinear, so we have to check maybe that it's a square. The next question asks, which figure would have 56 orange tiles? Okay, so this is where a lot of people were confused or unsure about what to do. So we're going to go back to this algebraic expression, and we're going to say, okay, 4n plus 4, and we know that we're looking for the answer 56, so we're going to make this into an equation. Instead of it being just an expression, we're going to make it into an equation by giving us an answer. And now all we need to do, I'm just going to move this up a little bit, sorry guys, so we have a little bit more space to work. 4n plus 4 equals 56. Because we know it's an equation, we can now solve it. So the first thing we need to do is we need to isolate this variable by removing this. So our next line will look like 4n equals 56 minus 4, right? Because we're taking this positive 4 and we're bringing it over to the other side. So 4n should equal 52. And then the next step is to get rid of this 4, right? The clinger. So divide that by 4 and divide that by 4. So we have n equals, I didn't do the math right away, 1 second, 1. I'm just going to do, that's 1, 3, so 13, my goodness. So this n equals 13 means in this figures, as we get larger, the 13th figure will have 56 orange tiles, okay? So this is the 13th figure is the answer. The next question asks, which figure would have a pond area of 121? So again, if we know that the blue algebraic expression is n squared, and we know that the answer is 121, then we can work this out. How do we get rid of a square? Well, we square root it, right? So we know that in order to get rid of this, we have to use the square root. So we're going to square root this, and then we're going to square root 121. And so n will then equal 11. So it's the 11th figure that would have a pond area of 121. Okay, so this is just a reminder that when we're given a question like this, where we're given an answer, we take our algebraic expression and we turn it into an equation. Okay, so that's it for this section. I'm going to probably add one more section on today. That's more of a grade 9 idea, but I thought it'd be a good thing for you guys to know. So take a look in a second, okay? Bye.